So on E, we can strategize. We can use, we can break up using the distributive property the best units to go with dividing by 6. So so let's take this example. We have 4 and 236 thousandths divided by 6. What we can do to make this a little simpler on us is we could divide the units up into ones that are easily divisible by 6. So if I look at 4 and 236 thousandths, I can see that I can split it up into 42 tenths plus 36 thousandths. So I can do 42 tenths divided by 6 plus 36 thousandths divided by 6. And that will take care of the whole number. So 42 tenths divided by 6 is 7 tenths plus 36 thousandths divided by 6 is 6 thousandths. And written in standard form, that would be 7 tenths with 6 thousandths. So 706 thousandths would be our answer. All right, let's take a look at the at number 3. I think maybe we should write it in unit form so we can see how it relates to all the other ones. If we wrote it in unit form, we would say 32 ones divided by 8 equals 4 ones, and we'd get our 4. Okay, and the second one on A, instead of ones, it's 32 tenths divided by 8 is 4 tenths. So in standard form, that would just be written as 0.4. As you can see, we have the same fact family. We have the 32 divided by the 8 here, and we have the 32 divided by the 8 here. But instead of ones, the second one has tenths, but it's still the same fact family. Okay, let's look at the next one. We have 81 ones divided by 9 is 9 ones. So the answer would be 9. And in the second example, instead of ones, we have 81 thousandths divided by 9 equals 9 thousandths. And to write that in standard form, we would write 9 thousandths. So the relationship shows how we still have the same fact family, whether we're dividing ones or whether we're dividing thousandths or hundredths or tenths. So, all right. Are the quotients below reasonable? Okay, for reasonableness, we're going to go ahead and estimate. As far as estimation goes, what I would really like to do is I would like to round it to the nearest whole number that's compatible with the divisor. So, for example, 5 6/10, it's close to 6, but it's not really compatible with 7 because it doesn't come out to be a nice, like when we divide it, it doesn't come out to be a nice whole number that's really easy to compute. So 5 6/10 divided by 7, instead of rounding it to 6, I would want to round it to something close to 6, but still divisible by 7. I don't know if that makes sense, but for example, instead of choosing 6, I'm going to choose 7, because if I divide 7 by 7, my answer would be 1, and that's really easy to arrive at. So I would round this to 7 and then divide it by 7, and that would equal 1. And as you can see, the quotient there is 8, that's 8 times our estimate, which is not close enough. So I would say no, not reasonable. Not reasonable because the quotient should be close to 1 whole. All right, in the second example, I have 56 divided by 7. Okay, so 56 divided by 7, I don't have to really round that because I know that's a fact family. So 56 divided by 7 equals 8. And 0 8/10 is not really close to 8. It's actually close to 1. So I would say no, not reasonable, because the quotient should be close to 8. Okay, and then in the last one, it says 56 hundredths divided by 7. Well, if I took 56 hundredths and I rounded that, that would be 1 whole. If I rounded to the nearest whole number, it would be 1 whole. And 1 whole divided by 7 would be 1/7, which would be close to 0 for my quotient. So I round this to 1. 1 divided by 7 would equal 1/7, which is close to 0. And if I look at my quotient is close to 0. So I would say that my quotient is reasonable. Yes, because the quotient is close to 0.